For this question, we are asked to rationalize this strange-looking fraction, square root 6 over square root 2 minus square root 12. The reason you may be asked to rationalize a fraction like this is because oftentimes mathematicians don't like to leave answers where you have a root somewhere in the bottom. Now, if you have two roots on the bottom of a fraction, what we'll do to rationalize this and change it to a non-root number is multiply on the top and bottom by something called a complex conjugate. In order to figure out what the complex conjugate is, you just look at the denominator, root 2 minus root 12, and change the sign in between. Once you know what your complex conjugate is, now we'll multiply. So we will write times root 2 plus root 12 on the top and bottom. We'll put both of those in parentheses also. On the top, we're going to distribute because we have a monomial times a binomial. On the bottom, we're going to use the FOIL method because we have a binomial times a binomial. We'll begin with the top and say square root 6 times square root of 2 plus square root 12. Square root of 6 times square root of 2 will give us square root of 12. And then we take the square root 6 times the square root 12, and 6 times 12 gives us 72. Therefore, that is our new numerator. Now for the bottom, let's look at square root 2 minus 12 times square root 2 plus 12. We'll begin by taking the first terms. Square root 2 times another square root 2 will give us an ordinary 2 without a square root. Any square root times itself just gives you the non-square root version. So we'll say 2, then take square root 2 times square root 12. 2 times 12 gives us 24, so we'll have square root 24. Then we take the inner terms. Negative square root 12 times square root 2 gives us negative square root 24. Notice I will write the roots underneath one another. And then we'll have negative square root 12 times positive square root 12. Root 12 times root 12 will give us 12, but since one is negative and one is positive, this will give us negative 12. Now notice that we have two square roots, one positive, one negative, but they're exactly the same number, square root 24, so these will cancel out. And so all we have left is 2 minus 12, and that will give us negative 10. This will be what goes on the bottom. So far, what we have is square root 12 plus square root 72 divided by negative 10. We can simplify this down a little bit further. Even though this fraction is already rationalized, we can simplify a little bit by looking a little harder at the roots and trying to factor out perfect squares from the roots. Remember, your perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, and 100. So we'll begin with square root 12. You might notice that square root 12 is divisible by 4, and we can rewrite square root 12 as square root 4 times square root 3. Because 4 times 3 is the same as 12. But square root 4 is actually just 2. And so square root 12 is really 2 root 3. We can do the same thing with 72. Those of you with a keen eye might notice that 72 is divisible by 36. So square root 72 we can write as root 36 times root 2. Square root of 36 is actually 6, so we have 6 root 2. We can now place 2 root 3 in the place of the root 12, and we can place 6 root 2 in the place of the root 72. So our new fraction will look like this once we do our replacements. We'll now have 2 root 3 plus 6 root 2, both of them over negative 10. Now we'll just divide the non-rooted numbers and simplify the fractions down. If we look at the first fraction, 2 over negative 10, and we're just looking at the non-rooted numbers, 2/10 can be simplified down to 1/5, but that negative in the bottom will change this to negative 1/5. So what we'll have instead is negative 1 over 5, and then that root 3 will stay on top where it is already. Then we'll take 6 over root 10 for our second fraction, and if we simplify this down, this will give us negative 3/5. So we'll say negative 3 over 5, and the root 2 will stay on top. And so this is about as simplified as we can make that weird fraction we started out with. But we have succeeded in rationalizing the denominator. Thank you for watching. We'll see you again soon.